All right, these are the free fall problems set 2 that Coach Pfaff has posted as an assignment. Number 1 says a rock falls from rest from a bridge to the water below. If it takes 3.5 seconds for the rocks to hit the water, how high is the bridge? Okay, so from rest tells us that the initial velocity is going to be 0 meters per second. It says it takes 3.5 seconds, so that is the time. We know that gravity is happening, so that is the acceleration, and that is negative 9.8 meters per second squared, and we want to know x. All right, so looking at these formulas over here, I'm going to choose, we have time. Okay, so I'm going to choose this last one over here. X equals xi plus vit plus 1/2 at squared. So we're going to label the initial position as 0, so we can cancel that out of the equation. We don't need to add that in there. The initial velocity, because it started from rest, is also 0, so we can get rid of that portion of the formula. So the formula, because of all those zeros, we can now cut it down to 1/2 at squared. And you can see here, he has the height equals 1/2 at squared as well. So we could have just used that one. All right, so x is the distance. We don't know. 1/2 negative 9.8, 3.5 squared. When I plug that into my calculator, I get 0.5 times negative 9.8 times 3.5 squared is negative 60. So the height is actually just going to be 60 meters. All right. It says what velocity was the rock? What was the velocity of the rock as it hit? So we want to know the final velocity. Using all this information up here as well, we're going to choose this formula. Oops. Vf equals Vi plus AT. Vf is what we don't know. Vi is going to be 0, so we can get rid of that portion of the formula. A is the gravity, negative 9.8, and T was 3.5. So negative 9.8 times 3.5 is negative 34. Okay, so it's asking for velocity, and velocity you do need direction because it's a vector quantity. So Vf equals negative 34.3 meters per second. And then when he says what is the speed, well, that is when the direction does not matter. So if velocity is negative 34, then the speed is just 34.3 meters per second. All right, number 2 says a ball falls from rest from the rooftop. All right, so this time we have the height, and we want to solve for t. So it says if a ball falls from rest, we know the initial velocity is 0. We know that x is 24.5 meters. How long is time? We don't know. And we do know gravity is negative 9.8 meters per second squared. All right, so I'm going to use the x equals 1/2 at squared. X is 24.5. I'm going to make that a negative because it's going down. And that's important because later you're going to need to take the square root, and you cannot take the square root of a negative. You will get an error in your calculator. So negative 24.5 equals 1/2 times negative 9.8 t squared. So I'm going to take 1/2 of 9.8. So 9.8 divided by 2 is 4.9. So this is negative 4.9 t squared equals negative 24.5. I'm going to divide both sides by 4.9, negative 4.9, and then negative 24.5 divided by negative 4.9 is 5, and that equals t squared. To get rid of the squared, you need to take the square root of 5, so square root of 5 is 2.23, so t equals 2.24 seconds. All right, now that we have the time, we can plug that into, we want to know the final velocity. So VF equals VI plus AT. VF we don't know. VI again is 0 because it starts from rest. Negative 9.8 in the vertical direction is gravity, is your acceleration, and then times 2.24. So negative 9.8 times 2.24 is negative 21.95 meters per second. And then if it says what's the speed, well, that's just going to be the 21.95 meters per second. Number 3, a ball is dropped off of a cliff and it takes 5.5 seconds to hit the ocean below the cliff. How tall is the cliff? Okay, so we want to know x. We know that time is 5.5 seconds. We know that if it's dropped, that means it starts from rest, so VI is going to be 0. We know gravity is negative 9.8. Okay, so I'm going to choose x equals 1/2 AT squared. X is what we're looking for, 1/2 negative 9.8. 5.5 squared. Okay, so if I plug that in, 0.5 times negative 9.8 times 5.5 squared is equal to a distance of 148.2, so I'm going to round off right there, meters. And yes, you do get a negative, but again, he's asking how tall, so we're going up in that situation. All right, what is the velocity when it hits the water? So again, we're looking for VF. Okay, VF equals VI plus AT. VI is 0 still, so we can get rid of that. VF equals negative 9.8 times 5.5. Negative 9.8 times 5.5 is a final velocity of negative 53.9 meters per second. Again, take away the negative for the speed, and you will get 53.9 meters per second. Number 4 says a ball is thrown straight up with a velocity. Okay, so now we're not dropping it anymore. Now we're throwing it up into the air. So the different things start to change a little bit here. So we give it an initial velocity of 25. So this time VI is not 0. It is 25 meters per second. It will fly up into the air and stop briefly. That means the final velocity at the top of its path is 0 meters per second. He lists that right there. How many seconds did it take for the ball to just get to the top there? So we want to know time, and we always have gravity is negative 9.8. All right, so looking at those 4 letters right there, I'm going to choose VF equals VI plus AT. Remember, A and G are interchangeable here. VF equals VI plus AT. VF is 0 equals 25 plus negative 9.8 times T. I want to know. So in this case, we're adding here, so we need to subtract the 25 from both sides. So you get a negative 25 on the left side times, and then negative 9.8 times T on the other side. Now you're multiplying, so you need to divide the negative 9.8 by both sides. So negative 25 divided by negative 9.8 is 2.55. So T equals 2.55 seconds. And there you go. All right, number 5, a ball is dropped from a height of 15 meters. How long does it take for the ball to hit the ground? All right, so now we have a distance. X is 15 meters. How long would be time? So T equals question mark. We have gravity, so A or G. I keep using those interchangeably because we're in the y direction. They are the same thing, so negative 9.8 meters per second squared. If it's dropped, remember that we have the initial velocity of 0, which is very important. And so I'm going to use this formula, x equals 1/2 at squared. Because vi is 0, I can take out that whole section of the formula, of the long formula, this part right here. All right, so 15, I have to make it negative because remember that when you take the square root, you're going to need a positive number to do that. And again, we're dropping it down, so we're going to make that a negative number. All right, negative 15 equals 1/2 negative 9.8 t squared, half of 9.8. Okay, so if you don't remember, divide it by 2, you get 4.9. Okay, bring everything else down. Now you're multiplying, so you need to divide the 4.9, the negative 4.9. Okay, so negative 15 divided by negative 4.9 is 3.06 equals t squared. To get rid of the squared, you need to take the square root of both sides. So the square root of my answer is a time of 1.75 seconds. Okay, so a bit of algebra there. You'll need to know how to do that in math for sure. All right, and then it asks what is the velocity of the ball when it hits the ground. Okay, so we're looking for the final velocity. So VF equals question mark. VF equals VI plus AT. VF I don't know. VI is 0. Negative 9.8 times the 1.75 seconds. That's 5. So here you had to get this one up here correct in order to get this one down here correct. So hopefully you're doing that all in the right way. So negative 9.8 times 1.75 is a final velocity of negative 17.15 meters per second. Okay, number 6, last one. Delete that 7. A ball is thrown upwards. Okay, so we're going in this direction. It takes 2.3 seconds to reach its maximum height, where it stops briefly before falling to the ground. What was the velocity as it was thrown up? So we want to know the initial velocity. We don't know. It took 2.3 seconds. We have a final velocity of 0 because it stops at the top, and we have the acceleration of negative 9.8 meters per second squared. So if I use this formula, VF equals VI plus AT, the final velocity is 0, the initial velocity we want to know, negative 9.8 and 2.3 seconds. All right, so negative 9.8 times 2.3 is a negative 22.54. Bring everything else down. So you're going to bring, because you're adding, okay, so you're going to bring this over here to get 22.54 meters per second. All right, there you go.